So we're going to be talking about a couple of different things in this lesson. This is lesson 5.2 from the CDE from the instructions. So this is, what is the value of Apple stock? Stock prices vary from day to day, making investments risky. How can we analyze the value of stock over time, and how could this help us make predictions for what will happen in the future? The value of Apple stock over a 14-day period can be modeled by A of T, where T represents the days after May 31st, and A of T is measured in dollars. The graph of A of T is shown below. So in this graph, in this graph, you'll notice that there is no, I don't know what it's counting by this direction, so that's kind of a problem for me. I would like to know what that is going the other way, but that's okay. And so that's problematic, but there's our graph, and so we're kind of thinking about this picture. So then it wants to know what's happening over the 14-day period. So this is a graph of 14 days. So day 1, day 2, day 3, day 4, all the way up to day 14. So what's happening? Well, I would say it's changing a lot. It goes up and down. You've got some peaks and some valleys and some weird kind of, this is strange what's happening here, where it's kind of holding steady for a little bit, but then dipping again. What is the highest value? I'd say it starts at its highest point right here. What's the lowest value? Well, that's here. So you're going to want to guesstimate what those two are. And so there you've got your A, your answer to 1 and 2. So take a minute, write those down. Highest value here, lowest value here. What's happening? You need to get your own words in there. So this is over a 14-day period. If you bought it on June 1st, that's because it was May 31st, right? This is that day. So if I buy it on June 1st, I bought it here. So does that change the highest value? Well, yeah, it does. Now my highest value is here. And so it changes where it's worth. Now, what if I was to buy it here, buying low, and sell it here, I'm doing great. If I was to buy it here and even sell it here at the end of the days, I still made some money. Whereas if I bought it here, I don't want to sell it at all until it gets back up to what it was before. But I could sell it right there and so on. So my maximum value has changed because my endpoint's changed. Okay, so that's the answer to number 3. On which days does the value of the stocks, is it changing the fastest? So that means both increasing and decreasing. And so what would that be? So let's just take a look at questions 2 and 3 with the picture, 3 and 4 with the picture right here. So those are the two I really want to focus on and where I'll start writing. So when is it changing the fastest? And I would say right here, if I looked at that average rate of change, that seems to be fairly fast. This one is slower, even though it's a big dip, because it happens over several days. This happens over one day. We went from around probably 226 or 7 down to 320. So we dropped almost more than $20 in whatever the units are going this way, but more than 20 points in one day. So that would be the largest rate of change over the period, because the slope is, so I would say that day 1, the value of the stock is changing the fastest, because the average rate of change, the value of the stock is not changing here or here, or, ooh, there it is, there's the flat for a while. So, and that idea of it's not changing here, here, and here is important. Where it's not changing is what we would call a critical point. And so we've got this flattening area right here for this one whole day where it doesn't change, just kind of holds steady and then continues to fall. And then it's on a rebound right here. Ooh, wait, you know what? I'm wrong. This is faster. That's the fastest rate of change. It is steeper than that. So those are the ideas. So you're kind of looking at average rate of change here. Or the derivative. Oh, it's A of T. A of T, excuse me. And so, and did they give me an equation? They did not. Okay, and so A prime, where I would say where A prime is the largest, would be where it's changing the fastest, or absolute value, right? Because you have to consider the absolute value. And it's not changing when it's flat or when it's turning around in those three turnaround points and one holding steady point. So what we've been talking about in this section is the extreme value theorem, which is what EVT stands for, extrema, and critical points. So we talked about extrema in Math 3 and even in Math 2 and 1, where we were talking about maximums and minimums. Those are the extrema. And then there was relative and local. Maybe you remember those words. So you can't quite see the numbers on the sides. Let me move this in. You're going to want to pause me here and get this written down. I'm going to keep talking. So pause me whenever you want me to stop so you can write. The extreme value theorem states that if a function is continuous on the closed interval from a to b, then f of x must obtain a max and a min on the closed interval. So it has to have a maximum and a minimum value. They can be the same because it can be a horizontal line, but there must be a max and a min. If it has an absolute max at c if f of c is larger than or equal to f of x for all the x values. It has a relative max at c if f of x is greater than all the f of x's near it. So the difference between absolute max and relative max, looking at this graph, this is a relative maximum, right? Let me highlight actually right here. That's a relative max because it's bigger than everything around it. This is an absolute max because it's the biggest. Then we've got our minimums. I will use a different color. So this is a minimum, a relative minimum. This is a minimum. This isn't, but it's kind of a critical one. And so again, we have another max right here, and this one is also relative because compared to everything around it, it's a max. But see how there has to be a biggest and a smallest on the interval because of the endpoints. So this is a relative min. This is a absolute min. These three are relative maxes. This is an relative, but this one is the absolute for this interval. So going back, absolute min when it's less than every value. It's when it's for anything near it. Critical points are points where the derivative is 0 or undefined. So that's really important. There is that critical points occur when the derivative is 0 or undefined. And so when you think about that particular one, the reason I marked this, going back to the graph, this one right here, is because the derivative is 0 right there. It seems to have a slope of 0, but it's not turning around, and that's kind of tricky, but it's still a critical point. So we actually have 4 critical points in this graph. These two, the endpoints, since the derivative is undefined at the endpoints, those are also critical points. Okay? So check your graph for which values do we have critical points. So again, I'd like you to try these. There are 4 of them with each other. Go ahead and try them. Pause the video. Try them, and I will answer them. When you unpause the video, all the answers will magically appear. Okay, so there are 2 values for which there are critical points on number 1. One of them is 2, the other one is at 4, because at 2 the derivative is 0, and at 4 the derivative is undefined because we have that cuspy point. Find the critical points. That will be when the derivative is equal to 0. So I took the derivative, set it equal to 0. I got 4/3. I realized I drew all over my graph, so I put it on the next page. And so anything works here. You need to have a max, but never talked about a max, except for that there's an absolute max here. So make sure that's the highest point on your graph. Make sure it turns around and is bottoming out around -1, turns around and is bottoming out around 3. It is lower at 6, and you need a cusp or a jump or an asymptote at 4. I didn't want to do an asymptote because then that would mix up with my maxes and mins, so I didn't want to do an asymptote. I'd say an asymptote's bad, but a jump or a cusp at 4. And that's that. Anything, there's a lot of different right answers for 3. For 4, I didn't actually write down the answer. I wanted to talk about each of them. So there exists a C where, since between -2 and 1, such that the value is 0. And since we surround 0 with -5 and 4, the IVT guarantees that this is true. So this one's talking about the derivative, which means we're talking about the MVT. So these two are both MVT. I don't know if it guarantees them, but they're both MVT. And this one is IVT. And then this one, there exists such that there's a maximum. That's EVT. So all of those are kind of represented here. So the IVT, let's just look at A and C, which are the IVT. Do we surround 0? With their endpoints? We do. Do we surround 3? Yes, we do. So those are both true. So that means they can't be the answer because they're both true. We're looking for something that could be false. Doesn't have to be false, could be false. So for the mean value theorem, that means I need to find the average rate of change. So 4 minus 5 plus minus -5 is 9. And so 3, and so that's 3. And so it's D is true, and C is not true. Let's see why the EVT applies. Since the derivative, since it's closed, it's continuous and differentiable. That means that the EVT applies, and therefore it's a closed interval. Therefore, there has to be endpoints that work. So there is an absolute max. There is the largest value on the interval because that's just what the EVT says. It just has to be continuous, and so it is. So EVT applies. So the correct answer there is B. It's the only one that can be. So there will be a web assign, and good luck to you, and I will talk to you when I see you next. Have a great day.